Sometimes integration by substitution can be done by pattern recognition. Suppose g is a function whose range is an interval I, and f is a function that's continuous on that same interval. If g is differentiable on its domain, and f is the antiderivative of little f, then if I integrate f as a function of g, and I have g prime dx in there, then this integral is going to become the antiderivative of f evaluated at g plus c. Now, a lot of times we do a u substitution, and I let u equal g of x, then du is g prime dx. Look at it this way. Big F is your outside function. Little g is your inside function. Then you have g prime. Then this becomes the antiderivative of f times g of x plus c. Let's do a couple of examples. Suppose I have the integral of x squared plus 1 squared times 2x. Now obviously this is my outside function, this squared function, and g of x is equal to x squared plus 1. Lost my pen here. All right, so g is my inside function, while f of x, I'm just going to use x, is x squared, okay, because this is the outside function. This is outside. This is inside. And it's unfortunate that we do tend to use x's in both. So f evaluated at g is equal to x squared. So this is x squared plus 1 squared. Now what is g prime of x? Well, that's 2x. So this part right here is g prime. So this is the integral of f evaluated at g of x times g prime of x, which is the antiderivative of f evaluated at g of x plus c. Now what is the antiderivative of x squared? Well, the antiderivative of x squared is x cubed over 3. So this is equal to x minus 1 cubed over 3 plus c. Suppose I have something like the cosine of 5x dx. Let me rewrite this as the integral of cosine of 5x times 5 dx. Now let me do colors here. My outside function, f, is equal to what? Well, my outside function is quite clearly cosine. Is cosine of u. And let me do the u substitution here because I think it's easier. G in this case is 5x. So g prime of x is 5 dx. So I have g prime right here, and this is my outside function. So this whole thing becomes, all right, the antiderivative of cosine is sine evaluated at that function, which is 5x plus c. Now it turns out if I integrate a constant times a function, that's just a constant times a function. So don't get confused just because I have numbers in there. So this is sine of x plus c. Now, sometimes you want to multiply and divide through by a constant. This one is not directly in the form. Let me rewrite this as 1/2 times the integral of x squared plus 1 squared times 2x dx. I haven't done anything. I'm multiplying and divided by 2. So this right here is f evaluated at g of x, while this part right here is g prime of x, where g of x is obviously x squared plus 1, so g prime is 2x. All right? So what does this whole integral become? It's equal to 1/2 the antiderivative of this, which is x squared plus 1, I'm just going to treat that as one thing, cubed over 3 plus c. So I'm going to rewrite this as 1/6 times x squared plus 1 squared plus c.